Hi everyone. In this video we're going to practice some unit conversions that will be useful for the physics regents, and we're going to use something called dimensional analysis. So first we're going to talk about what a conversion factor is used for. A conversion factor just tells you how two different units are related. So that could be something as simple as 1 day is the same thing as 24 hours. So we all know that there's 24 hours in a day. But if I wanted to write that in the form of a conversion factor, I could write it like an equation like this. 1 day equals 24 hours. If I were going to do dimensional analysis, which I'll show you in a second, I might need to put that in a fraction. And there's two ways I could put this in a fraction. I could write 1 day over 24 hours, or I could write 24 hours over 1 day. So you could call all three of these formats conversion factors. The equation, or this fraction, or this fraction. These are all examples of conversion factors. We're not really going to be using this one in our problems in this video. We're going to be using different conversion factors, but this should just give you an idea of what that means. So the first question says, what is the conversion factor between centimeters and meters? So I want to know basically how centimeters and meters are related. And I want to use the physics regents reference table because that's what I'm going to have during the test. So it gives us this prefixes for powers of 10 chart, and specifically I want to look at this line that says centi c 10 to the negative 2. What this really means is that 1 centimeter equals 10 to the negative 2 meters. It's very, very important that you don't accidentally write 1 meter equals 10 to the negative 2 centimeters, because that's not true and you will get all your answers wrong. Sometimes I like to think of a giant 1 popping up right here before all these prefixes. 1 centimeter equals 10 to the negative 2 meters. Now this could be written as 1 centimeter over 10 to the negative 2 meters, or it could be written as 10 to the negative 2 meters over 1 centimeter. And when we do our actual problems, you'll see how you're supposed to figure out which one to use. Next, we're going to find the conversion factor between kilometers and meters. So we're going to use kilo as the prefix, and it means that 1 kilometer is equal to 10 to the 3 meters. So that fraction can be written in two different ways. The last one we're supposed to write down is the conversion factor between kilograms and grams. We're still looking at kilo, but this time instead of thinking about kilometers, we're thinking about kilograms. But the format is still the same. Imagine that giant 1 popping up right here. 1 kilogram equals 10 to the 3 grams. And of course, again, we can write that fraction in two different ways. So let's say we're trying to convert 2.7 kilometers into SI units. First, we have to remember that SI units are the units that you're supposed to use when solving physics questions. So instead of kilometers, I'm supposed to be using meters. So I want to try to convert 2.7 kilometers into meters. The way this graphic organizer works is I put in my starting value here, 2.7 kilometers, and my conversion factor goes here. I need the conversion factor between kilometers and meters, which we already have written down. 1 kilometer is equal to 10 to the 3 meters. So I put kilometers in the bottom of my fraction because I want to be able to cancel that out. And I put 10 to the 3 meters on the top because that's what I want to end up with. So we talked about how there are always two different ways to write the fraction, but there's only one right way for each given problem. In this case, if I flipped it, I'm going to get the wrong answer. So it's important that 1 kilometer is on the bottom for this example, and 10 to the 3 meters is on the top for this example. That lets me cross out kilometers, because if something's on the top and the bottom of a fraction, I can cancel them out. And then I just can plug this into my calculator. I'm going to be doing 2.7 times 10 to the 3 divided by 1. And that gives me 2,700 meters. The next example is converting 50 centimeters into SI units. So again, I can't really use centimeters in a physics question, but I can use meters, which is the SI unit. So I'm going to use my conversion factor between centimeters and meters. 1 centimeter is equal to 10 to the negative 2 meters. And again, I want centimeters to be crossed out, so I'll put that on the bottom. And 10 to the negative 2 meters can go on top, because that's what I want to end up with. That allows me to cancel out centimeters. And so I'm left with 50 times 10 to the negative 2 divided by 1, whatever that gives me in my calculator, and I'm left with meters. 0.5 meters. That's my answer. The last one we'll do is converting 84 grams into SI units. Now, SI units for grams should really be kilograms. Remember that mass is always measured in kilograms when we're doing a physics problem. You're not allowed to use grams. So I need the conversion factor between kilograms and grams, which I already have written down on my worksheet. 1 kilogram is equal to 10 to the 3 grams. Now this time, I don't want the kilograms to go on the bottom. I actually want kilograms, so that goes on the top. The 10 to the 3 grams goes on the bottom. So there's not really, it's not something that you can always count on having the kilograms or the kilometers or the centimeters. That's not always going to go on the bottom just because it did for the first 2 problems we worked on. So you really have to kind of reason through it like this. What do I want to cross out? I want to cross out grams. Grams has to go on the bottom. I want kilograms as my answer, so kilograms should go on the top. When I plug this into my calculator, I'm doing 84 times 1 divided by 10 to the 3. This is another common mistake I see. People will just do 84 times 10 to the 3. The reason it's on the bottom of the fraction means that I have to divide. And I get 0.084 kilograms.